Let's break down this high-yield MCAT problem in 60 seconds. Buffers are one of the most highly tested concepts on the Gen Chem portion of the MCAT, so it's essential you know how to not only identify a buffer solution, but calculate the pH of one as well. A buffer is a solution that is resistant to a change in pH. Essentially, you can think of buffers as a shield protecting the solution from anything that might alter its pH. In order for a solution to be considered a buffer, it must meet the following requirements. Number 1, only weak acids and bases can make buffer solutions. This means that the Ka or Kb of our weak acid or base should be between 10 to the negative 4 and 10 to the negative 11. We also need to keep in mind that for a buffer, we need a conjugate pair. For example, if we have acetic acid, which is a weak acid, you must have its conjugate base acetate to be considered a buffer solution. Number 2 states that the ratio of our conjugate base to our conjugate acid in the buffer solution must be between 0.1 and 10. Anything outside of this range would throw off our buffer. And finally, for number 3, the concentration of your acids and bases in the buffer should be between 10 to the negative 3 and 1 molarity. This just prevents you from having too little or way too much of your buffer solution. If all 3 of the conditions are met, we can confirm we're working with a buffer solution. On the MCAT, it's super high yield to know that you can calculate the pH of a buffer solution with the Henderson-Hasselbalch equation. pH equals the pKa of the acid you're working with plus log of the conjugate base over the conjugate acid concentrations.